Hello students, in this video we are going to see the different types of errors in programming, and also we are going to see how to debug the code which we have written in the previous video through a simulator available in Acmal Studio 7. While programming we encounter three types of errors. One is syntax error, second is logical error, third is real-time error. Syntax errors are due to misspelling or missing any semicolon or equal sign. It's even like if we have not defined any variable and we are using it in the program, then it will show it as undefined symbol. Like this kind of errors are called syntax error, and this can be cleared or identified and rectified by the compiler, or building the uh, source code will result in identifying and rectifying the errors. Next error is logical error. Logical error is due to wrong arithmetic operation or using wrong pin number or register may result in logical error. Logical error, for example, instead of doing a addition of two numbers, by mistake uh, typed multiplication of two numbers, this will result in the value. It cannot be identified by the compiler, but it can be only uh, by testing the code or debugging the code, we can identify that. For debugging the code, we have various simulators. Followed by this, even though we have cleared the syntax error and logical error of our program, there will be some real-time error existing due to physical limitation of the hardware. There may be a contact problem, or there may be a hardware limitations like current or voltage limitations in the hardware. Due to that, we may experience some real-time problems. So those are real-time errors. This can be identified and rectified by prototyping the hardware. Next, after this, we have to find the logical error. Uh, to find the logical error, we need to debug the code. So go to debug menu, start debugging. So it gets into the debug window. Here is our code, and there is a pointer here, yellow pointer, which indicates the line which is about to be executed. It's the line which will be executed next. Here we have processor status, memory window, the variables or the register contents. All these things we can see in individual windows. Here we are going to manipulate the IO port C. So we need to see what is the content there in the IO port. So go to this icon, IO icon, click that. The IO window will open here. Click on IO port C. You can see IO port name, port C, DDRC, and pin C. These three are the registers corresponding to the port C. Port C is the output pin, or if we want to access the port as output, we have to write a value into port C, and if we want to use it as an input, then we have to use pin C. To configure the port C, we have DDRC and their corresponding address in hexadecimal form, and their corresponding value in hexadecimal form, and individual values. It is represented over here. If it is blank like this, then it is 0. If it is 1, it will be highlighted as red color. Let's see that. Before that, we will see how to execute the program. You can run this code continuously without any stop. You can run it continuously by clicking this button icon, continuous, or F5 as the shortcut, or you can run step by step by clicking F11 or clicking this icon. So, the same icons will be available here in this debug menu. Step into step and step out, a continuous execution like that we can have. One more advantage of using IDE like this is we can add a breakpoint to our code, and we can stop the execution of the program and see what is the status of the program at that particular instant. To add a breakpoint, double click over here. A red mark will be added in this space, which indicates the breakpoint. So I add two breakpoints, one over making the port C as 1 and another for port C as 0, and I'm going to run it. I said this icon will make the program run continuously, but if there is any breakpoint, it will come and stop over here. See, the program got stopped over here. That means the breakpoint pass will pass the execution of the program. It is not stopping, it is passing the execution of the program. We can resume it back by clicking the continue icon again. So it goes to the next breakpoint and stops there. So the next breakpoint is to make the port C pin number 0 as 0. So this is the statement that will be executed next. Meanwhile, you can see here the value of pin and DDRC and port C. It is highlighted because this particular bit is having logic 1, all others were having logic 0. Now since this statement got executed, you can see this bit got cleared, so it is 0 now, and 1, 0, 1, 0, like that. It keeps toggling infinitely, so it looks like the LED is blinking in the hardware. To stop the debugging option, click stop debugging. So what is the use of debugger is to find the logical error. If I have made a logical mistake, like instead of making accessing port CP number 0, I have accessed port CP number 1, that is a logical error. This error won't be highlighted by the compiler. It can be either by identified by simulator or directly putting the code into the hardware, so that this simulator helps us in identifying logical error. Thank you.